Consider unstructured raw data such as weblogs, which are stored outside of a database. In a new trend, these types of raw data are hosted on infrastructures such as the Hadoop framework, which encompass hardware and software support, including new file systems, query languages, and appliances. The traditional method of accessing and analyzing unstructured raw data were complicated and did not always facilitate deep analysis. The DB2 custom analytics solution can help integrate dynamic results acquired from Hadoop with relational data into ongoing processes with SQL statements. You can leverage the strengths of the Hadoop infrastructure while taking advantage of the traditional data warehouse strengths such as direct SQL governance and control for end users and applications. In this example, the web logs are stored on a Hadoop cluster. To access these logs, you would traditionally take the following approach. First, load the data into a database. Secondly, write Perl scripts to filter and massage the data. Finally, produce reports against the massaged data. You might lose a lot of valuable data if the script is only implemented to handle generic cases. It is difficult to write a thorough script because you do not always know the exact structure and content of the web logs. As the business analysis requirements change, you would need to write a different set of scripts. As well, analyzing the web logs together with existing relational data requires additional implementation and processing. With this new DB2 solution, all the external scripts can be retired. They are replaced by two DB2 Java user-defined functions. First, use the submit function to submit a query to the Hadoop cluster. A Hadoop distributed file system result handle is returned containing the locations and schema of the result. The actual result, the Hadoop file, is still stored on the Hadoop cluster. To access the Hadoop data, execute an SQL statement with the second DB2 Java function, the read UDF. The HDFS read Java UDF accesses the Hadoop file based on the result handle and returns a table of data. Once the table is returned, you can use any of your analysis tools to generate reports based on the data. Because the UDF uses the new DB2 generic table feature, it produces different customized result sets based on different unstructured data inputs without requiring a new function definition. If you have other data in a DB2 server or any other database, you can now use a single reporting application to access and join both sets of information. This gives you the flexibility of creating any complicated and detailed analysis you require. Let us go through a specific example to see how we use DB2 to integrate both raw and structured data and to access and analyze these data accurately and efficiently. In this example, we want to analyze the web logs to determine the most popular topics in our online information center. You can see this weblog is stored in a Hadoop cluster. We want to correlate this data with our customer support data. Our problem management reports, PMRs, are stored in a relational DB2 database. In this example, we are using IBM Cognos, but you can use other business intelligence and business performance management software or simple SQL statements. As you can see in the reporting tool, only two jobs are necessary. The first job uses the Hadoop MapReduce technology to prepare the weblogs for querying. The second job actually reads the data from the Hadoop cluster and outputs results in a report. Now let's open the Cognos Design Studio and take a look at the SQL used for the MapReduce job. We see that this job contains only one query. The SQL invokes the Jackal submit UDF to submit a Jackal query. We need to specify the IP address of the Hadoop cluster, the port number of the Jackal server, and the location of the weblog we want to access. The Jackal query contains the fields we want to return, as well as any filtering and grouping operations. We've created a simple table that contains the job ID and the result handle for the Jackal query. Once the job is completed, a row is written to the table. This helps us keep track of the job status. Let's run the MapReduce job. Once the job is completed, we can see that it has job ID 68. The result handle for the Jackal query contains information such as the Hadoop cluster IP address and the mapped and reduced file stored in the cluster. We are now ready to access the information stored in the processed file for our reports and analysis. Here is the report we are using to retrieve the weblog data from the Hadoop cluster. The SQL statement calls the user-defined function called HDFS read, which accesses the data in the Hadoop cluster with the job ID specified in the report. We have other statements in the job to help us analyze the data. We are also accessing customer service data in the form of problem management reports, PMRs, which is stored in a relational database. We query the PMR table and list the hot topics that cause customers to frequently call customer support. We want to combine the product documentation hot topics and the topics with a high PMR rate. Once we have all of the relevant data ready, we use a report to graph the result for easy visual analysis. Let's run the IC versus PMR report job, which will read the data from the Hadoop cluster and the DB2 relational table. Click Run and enter job ID 68, since this ID was generated from the MapReduce job we ran earlier. Once the job is completed, we can obtain and review the report. The report shows analysis for the top 20 topics accessed in the Online Information Center, based on the weblogs, and the top 20 topics for the problem management reports, based on the PMR database provided by the customer support team. The blue color represents PMRs, and the yellow color represents Online Information Center pages. At a glance, you can see the popularity of the topics and make accurate business decisions. You can quickly see that some topics are all blue. These topics are frequently used in a PMR, but have no related documentation hits. We may want to provide additional documentation for these topics to help customers find the information they require online rather than by calling customer support. Consider unstructured raw data such as weblogs, which are stored outside of a database. In a new trend, these types of raw data are hosted on infrastructures such as the Hadoop framework, which encompass hardware and software support, including new file systems, query languages, and appliances. The traditional method of accessing and analyzing unstructured raw data were complicated and did not always facilitate deep analysis. The DB2 custom analytics solution can help integrate dynamic results acquired from Hadoop with relational data into ongoing processes with SQL statements. You can leverage the strengths of the Hadoop infrastructure while taking advantage of the traditional data warehouse strengths such as direct SQL governance and control for end users and applications.